Have you ever wondered how your favorite radio station reaches your ears? Or how your favorite smartphone connects to the internet wirelessly? What about the role of radio waves in modern technology or their impact on space exploration? Join us as we unravel this topic. Good day, you Spy. My name is Chini JD Makulangan, and I'm with Jayasin Maisel Ortega. But first, let me explain something. Electromagnetic radiation refers to the waves of energy propagated through space or a material medium, typically in the form of electromagnetic waves such as light, radio waves, microwaves, X-rays, and gamma rays. These waves consist of oscillating electric and magnetic fields perpendicular to each other and to the direction of propagation.
What is electromagnetism? Dictionaries defines electromagnetism as subdivision of physics that is concerned with the study of the interacting relationship of electric currents and magnetic fields. These are the types of electromagnetic radiation: radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma ray. This is an example of the electromagnetic spectrum.
Now, let's proceed on knowing what is radio waves. Radio waves are a type of electromagnetic radiation with wavelengths ranging from around 1 millimeter to over 100 kilometers. They are commonly used for communication, including radio and television broadcasting, cell phone signals, Wi-Fi, and radar. These waves have relatively low frequencies and long wavelengths, allowing them to travel long distances and penetrate through obstacles like buildings and foliage. In addition, radio waves, also known as radio pulses, are also considered to be one of the most important discoveries the human has ever had because it made communication more efficient.
How was radio waves produced? Heinrich Hertz verified the existence of radio waves or pulses in the late 1880s. In 1879, the 20-year-old Hertz was seriously thinking to prove Maxwell's theory of electromagnetism as part of his study in Berlin.
And by 1886, while continuing his quest to verify the theory of Maxwell, he witnessed an electrical spark in one of his devices. That spark directed him to deep thoughts and questions. Hertz put up his spark gap transmitter, as he was already experimenting to prove Maxwell's theory. He started producing them using a piece of electrical equipment called induction coil. The induction coil converted low voltage direct current electricity from a battery into a high voltage alternating current electricity. The electricity crossed a small air gap at consistent intervals as a spark. Hertz observed that sparks cause an aggressive pulse of electric current within the copper wires leading out to the spheres. These uncertain electric charges produce electromagnetic waves or radio pulse or radio waves. The radio waves spread out at the speed of light through the air around the wire.
At this point, Hertz put two hollow spheres with the size of 30 diameter with 3 meters apart. These are what we call spheres that serve as the capacitors across the central gap that produces sparks, which is called the magnetic induction. And then the sparks flew between spark gaps.
He then further observed that the sparks that glided across the main spark gap, also known as transmitter, typically soared across the secondary gap or receiver. Further experiments with Hertz did show that the flickering at the main gap produces regular electrical waves that is moving back and forth. He believed that the circuit was vibrating, which is determined by electrical properties called inductance and capacitance. He identified a phenomenon called self.
The sparks were produced by the onset of the electromagnetic waves from the transmitter, creating fierce electrical vibration in the receiver. Hertz not only proved Maxwell's theory, but he also was able to generate radio waves.